I'm John Cronin with the Invent Anything podcast series, and the channel that we're on now is Inventors at Work. And I'm pleased to have two really great inventors with me today. Dr. Kripa Varanasi, who's at MIT. He'll talk a little bit about that and his background. And David Smith, who is actually the CTO of a company called LiquiGlide. And these guys met, I believe, at MIT. So proud to have you both on. The point of this is to get to know them and hopefully at the end give you a website where you can go vote, because they're in the running 3 out of 600 as a finalist in the European Patent Office's sort of Best Inventor Awards. So we're hoping that you watch this and then vote for our friends here. So let's start off with Kripa. Maybe you could tell us a little bit about yourself and your background, and a little bit about how you got involved in LiquiGlide.
Yeah. First of all, thank you so much for doing this. I'm delighted to be here with Dave. I'm a professor of engineering at MIT. My work revolves around understanding physicochemical interactions at interfaces. Interfaces is the boundary between two phases of matter where all the action is, whether it's energy, mass, momentum, charge, or biological interactions, right? And so what we do is fundamentally alter them to improve efficiency and come up with new product paradigms and across a range of industries, whether it's energy, water, agriculture, consumer products, to biomedical areas. I mean, my journey started as a engineer in India, in one of the Indian institutes of technology, where I learned a lot of fundamentals. Then came to MIT for my graduate studies, and learned a lot about both knowledge, but also how do you use it, how do you make it real. MIT was awesome about teaching both science, engineering, and entrepreneurship. And then I went off and worked at General Electric company for a few years in their R&D labs and interfaced with energy aviation businesses. And so learned a lot about how to take ideas to market at GE and what it means. And so I came back to MIT as a faculty member in 2009. And with the idea that this whole interfaces is such a such an area that has not really been fully exploited. So we dove into the fundamentals, but also with the eye towards, hey, can we change this to change certain fundamental paradigms? And in that process, my first set of students, Dave was one of my first graduate students. We started on this problem of preventing clogs and reducing friction in pipelines, and things like certain things called hydrate plugs and things that could be catastrophic. And together, Dave and I invented this technology called liquid infused or liquid impregnated surfaces, which basically can fundamentally change what is called the no-slip boundary condition in fluid mechanics, which has been the reason why things stick, liquids stick to solids. And so we invented this, and we found that, hey, this could have so many different applications. One day, my wife was trying to get honey out of a bottle, and she was struggling with it. And she said, why don't you solve this problem? And that got us to thinking about packaging. And we found that our world is surrounded by so much packaging. And rest is history. But Dave and I then, and Dave made this amazing video with the ketchup bottle that kind of went viral. But we developed the science behind this, which we can talk more about later on. But that really enabled us, along with thinking about how to scale up simultaneously, and doing the manufacturing part as well, allowed us to take it to market. And I continue to work. So I'm a co-founder of LiquiGlide, and I'm on the board of the company, and work with Dave and others there very closely to get these products out there.
Wow, fantastic! And we'll come back to the science and some of the applications, Kripa. But let's jump over to Dave. Hi, Dave. How are you? It'd be great to get a little bit of your background and your side of this story as we start.
Sure. Thank you. So I'm a mechanical engineer. I'd say first and foremost, maybe a scientist. My undergrad, I got very, very interested in this research I was doing related to like salt wires absorbing water and breaking up into droplets. And to understand that problem, I had to like dig into a textbook on surface science and ended up studying the whole textbook, being really interested in it. And that was my senior year of my undergrad. Got an MIT, became really interested in the research Kripa was doing. And as he mentioned, interfaces are everywhere. He had endless applications for this. And I was excited by his vision to really, engineer interfaces to solve all kinds of different problems. And I'd say while at MIT, he got sort of an entrepreneurship kind of knack, which really is very similar to having an inventorship knack. Because to me, that way motivated me to want to come up with original ideas or to build on original ideas also. And anyway, it was a natural thing for us to think about we were trapping liquids in surfaces for other reasons. And the idea of trapping lubricants in surfaces was a very natural idea. But what we found is actually the challenge was creating stability. So really, I guess sort of what I think the key to this invention is really understanding the physics, getting the thermodynamics and fluid mechanics right. And with that, we realized how to make this effect work. First, experimentally, you couldn't just come to it. Actually needed to have, sound thermodynamic principles in a model. And from that model, we were able to make it work. And we even found ways to use the model to, create practical versions of this. Yeah, I guess that's sort of maybe the type of inventor I am. It's more of a starts from a scientific foundation.
Right. Well, wonderful. And, for inventors that listen in onto this channel, I think you've described kind of a journey that you've been on, and every journey is a little different. But one part of this journey, which you haven't even talked about yet, and maybe I'll go back to Kripa, is, there are graduate students and there are graduate students, right? And I'm sure, Kripa, you don't form a company with every one of your graduate students. So what was really special about, finding David and his passion to form LiquiGlide?
I think from I still remember my first meeting with Dave. He came in, he talked less, and but he had an intensity about himself, right? So I gave him a book about I think it was gas hydrates, and I didn't expect him to read the whole book, but within few weeks it was like all done, right? So
Right.
So there was clearly a great intensity about him, and both of us had the dream of entrepreneurship, of starting something.
Yeah.
And here were a number of problems that we could really solve, and it was really kind of I was able to instill in him this problem solving thinking, and also saying, hey, we could do this, we got to protect it, because we're inventing new things, then that's valuable, then we can go start a company.
Right.
But I think we would debate, and I'm free. I always say I can be wrong. So we could talk about kind of create an environment where students can freely debate and freely discuss ideas. And Dave really embraced all of that. So we could constructively build upon each other and debate to reach a good place. And lo and behold, we've invented a whole platform that could be applied everywhere, right? And I think it was crucial to have that back and forth, and really dig in. And Dave was wonderful about all of that and very tenacious about things. as you know, in science, the first experiment never works, right? So,
Right, exactly.
so we need both the intelligence and the tenacity, which both he had. So it was terrific to work with him.
Yeah, that's super. And I think for any kind of student who might be listening to this, wouldn't it be great to have Kripa as a professor, because a lot of professors I know are not that open to debate with their students and to form this kind of environment for inventorship. But Dave, on your side of that story, I mean, was when we look at Kripa, was he kind of the average professor? I mean, obviously, you haven't started other companies with other professors either. So, or I don't know, maybe you have, but what did you see from your side?
My standpoint, I mean, I interviewed with other professors, and it was an easy choice for me to want to join Kripa's lab. He was so practical. He had just come out of GE, and he had like lots of real problems to solve.
Got it.
And like more problems than we could, for work. We always had like 10 different projects going on in his lab at the same time, because there were so many possibilities. And it's like Kripa described, it's very easy to debate openly. Felt like just as much as a mentor as a partner. Like any, we'd spend hours in his office, like, I don't know, twice a week from like 5 p.m. to 9 p.m. Just working through ideas and working things out on the whiteboard, and I loved it.
Yeah.
And I doubt many other professors would take the time to do that, but I think that model is going to lead to a lot of great things.
Yeah, absolutely. So kind of like the capstone this, as you two were meeting, you both had an intense or passionate interest in this space. And you went from sort of distraction of wanting to be in an area to then doing something which is hard work of the inventor, which is to study and to learn and to get deeper and deeper into the science, to know how things work, not just what do you want to do. And once you get to how things work, then all of a sudden it's a whole different type of invention, trying to apply that how into an application that actually does work, which then requires another round of real experiments and things like that. But so many inventors that I've met over the years, thousands that I've worked with, getting that first experiment, a lot of people might just give up. But somehow you went past that. And then at some point, I don't know which one of you, or maybe both, recognized the potential of what you had, because maybe you could talk about that, Kripa, to start with. When did you kind of recognize, the potential? I know, Goodyear, when he invented the vulcanization of rubber, it was an experiment. Sulfur would get poured on the rubber that he was experimenting with by accident. And when he picked it off the stove, he knew that it was hot, but it wasn't sticky. And that was a major discovery by him. But I can't talk to Goodyear because he's not around, but I can talk to you guys, because there must have been a time when you absolutely saw this work, where somebody must have looked at each other or something and recognized what you had. Could you describe that? Because that's a really cool part of being the inventor, which is it works, right?
Yeah, I mean, indeed. I think so. I worked for a number of years on what are called these lotus-inspired surfaces, or which are basically called super hydrophobic surfaces,
right?
Which are textured surfaces that have air that allows them to create this really amazing water repellency. But then the moment you put an oil on it, it is gone. Or the moment you go to other fluids which don't have this property, or when you condense the same water onto the surface, it doesn't work because of a different mechanism of the way water gets onto the surface.
Yeah.
And so based on all of this, the idea was, can we, instead of having air, can we have some other fluid in there? And that's kind of where we had a gut feeling that will work, right? And so, right off the bat, when I started at MIT, this was a topic that we were looking at, and how do you kind of infuse or impregnate textures with liquids, and how can you then realize that kind of a property? And I think that's where, there were a number of initial experiments that worked really well. It was exciting, but, not every system worked well. And that's where we dug into the thermodynamics and got the this phase map, which I think was spectacular. I think that's kind of where we are able to see, hey, there are so many different thermodynamic states of which only few actually
Right,
matter. And
right,
actually our invention, our patents and all use that to get really good claims as well. And I
right.
think that was a back and forth process. Dave and I, would discuss whiteboard, as he said, and they would go back, do the new experiments. And it was I don't know of that one moment, but it was this sort of a collective
Okay,
what do you call, we knew we had something great. We needed to hone in and get to that point.
yeah.
I would
So
say
Dave,
yeah,
go
go
ahead.
ahead.
No, I was just gonna say, and Kripa brought this up, which is one of the questions I really wanted to ask about. There was, instead of an aha moment, it sounded more like an aha gut feeling, that you knew you were on the right track and you did process optimization in the phase diagram to figure out that there was unique areas in the phase diagram you could capitalize on, then you build into that. And I know you had to solve problems, not just the physics of what you're doing. You had to figure out the equipment, how to make it impregnated. There's a lot there. Maybe you talk a little bit about, now that you understand the science, Dave, how do you start to make it more practical? How do you get the equipment designed or all that?
Yeah. So I guess it started like Kripa's lab. In his lab, he focused a lot on manufacturability, and so I guess we implemented lots of processes in his lab that are
Got it.
scalable. One was spray coating, and so I thought, all right, we know what kind of structure we need the surface to have, what kind of properties we needed to have. How can we make that with the spray? And with materials that are safe and flavorless and odorless, because at the time we were thinking, let's try to make something for ketchup, and tried something, and it just worked. And because in a way, I mean, there was a lot of research into which materials we want to use. Once you have the materials and you have some understanding of how to create the structures, it became just putting it together.
Right.
And
I'll bet you, Dave,
it worked out well.
I'll bet you, Dave, there's a lot of learning on the equipment and how to even measure the things
Yes.
you're trying to measure. It must be something. Go ahead, Kripa.
No, I was just going to add to what Dave said, in the sense, we a lot of our science was done on highly controlled features that we made in the clean room, and Dave was making all these samples in the clean room, and we did a lot of careful experiments to understand all these different thermodynamic states. But then we of course knew that we cannot make these in a clean room. So we can't invent a new manufacturing process, because that's very hard to actually get things out. So while we are doing the science, we've been thinking about scale up, and which is why we said, the industry, there's all these spray based solutions. So we started looking at, can we do sprays that get us the same type of features that we get when we do from our physics? And I think that sort of went in hand, really, of doing the science and scale up together. And I think broadly, if I speak about, what's happening in our country also, is we should the manufacturing step is a key step, because you learn so much, you invent so much in the process. And I think doing the science and scale up together, it has really helped us to say, a few years we learned something and we could go to market, right? So I think that's a crucial step that we did, which not many labs and others do, because they go serially. Okay, we got this is working on a coupon SAM. Now how do we scale up? But it can take forever then, right?
Yeah, it's amazing. Now you're talking about inventing manufacturing processes. So you go from this broad concept to the physics, trying to invent the physics of making it work for you. Then you're trying to invent the compositions of matter, how to actually make the solutions, and then you're inventing the manufacturing processes, and so you're not just inventing one concept, you're inventing a whole world and solving these problems. It might be good. Sorry, go ahead, Kripa.
I said indeed that's the case, and I think when Dave made that ketchup bottle, he was armed with all the thermodynamics and he knew what.
Yep. So Dave, Dave showed me one of the products that you're actually working on with LiquiGlide, and I think LiquiGlide, maybe you could talk, Dave, a little bit about LiquiGlide, and you've had a very successful raise of money, you have investors now, you have a real company here, but I think the audience would love to see, I know they could go to see some of your videos, but love to see what you're working on right now as a product.
Yeah, so one of the products we launched, or Colgate launched, is a new toothpaste in a brand new type of package for toothpaste.
That's incredible. That's toothpaste in there.
This is toothpaste. Yeah, and this bottle is only possible because of our coating. If you put regular toothpaste in a bottle like this without a coating, half of it would be stuck in the package. It'd be a horrible experience. So this allowed a really new and better experience that lets you get all of the toothpaste out.
That's incredible. And that's a clear bottle, so you can see it working, right?
Yep.
And that, does it add a lot to the cost of how you make this bottle?
No, it's we make it from common inexpensive materials. So it's a pretty simple solution to an important problem.
I want you guys to invent something like that for my teeth, so the stuff just falls off my teeth. That's pretty cool. And not only that, but the idea of having a product that does that. I know I saw this in a couple of your videos, but not only are you not wasting toothpaste because you get it all out now, right? This has got to be good for the environment, right?
Absolutely.
Yeah, absolutely. I mean, I think from a sustainability point of view, there are a bunch of benefits. One is, of course, it's zero waste, so you're not wasting product. And imagine that when product is stuck inside packaging, and you may think you're throwing it out into a recycle bin, that product needs to be cleaned. And so if it is not removed, then most likely it ends up in a landfill. And so there is a significant water footprint that's associated with it, with which we also eliminate. And then finally, we think about CO2 and CO2 footprint of various aspects of this. So by not wasting, the CO2 footprint of the wasted product is no longer there, right? So, like if you just throw away the product remaining, then it's all ending up in the landfill, and the CO2 that went into making it, the energy that went into making the product is buried with it. So we have multiple shots on the goal here in terms of sustainability. We can make packaging a lot more, like, instead of jars, which use a lot of plastics, you can reduce all of that. We can make products more concentrated, so you're not shipping air or water all around, and overall can have a cascading effect on really sustainability in packaging and other areas.
Yeah, I sense, I think right now, I was looking at your 11 or so patents and applications, but it appears to me there's probably hundreds of patents in this space for you guys. You're just getting started. And I know I want to move on to the patent process next, but I mean, I could talk to you guys for hours about all sorts of applications. But one question I had, and I think that other inventors and people watching this might have, is if I took that bottle that you have for ketchup, the exact same bottle, and everybody hacks everything, right? So after I've used my toothbrush, I've got this empty tube. Can I put ketchup in it, and will ketchup work in that same, or do I need to design the impregnation for different products?
So, you might see a temporary effect with ketchup, but we have to design for the shelf life of the product, and we have to design uniquely around different products.
Got it. So every single product is going to have invention to it.
Yes, I mean, sometimes the one coating will translate to another application. Like this works for a number of lotions also.
Okay.
But ketchup definitely requires a unique coating. Mayonnaise has another unique coating.
Yeah. Perfect.
Just to add to that, I think what we have are platforms, and our patents or our foundational patents are, not a method of making something, more of an article, right? So we actually try to patent the concept itself, in the sense, we have our thermodynamics. It shows us, the parameters that control this, and so we are able to, use that really to to have our patents more around the concept. And then of course there are a lot of follow-on patents on methods and more specificities around it. But that has enabled us to really give us wide protection.
Right.
And so it's not just about, hey, this is for toothpaste, or this is for this or that. It is patenting the concept, and then we have platforms that can then apply to various product lines.
That's really clever. So maybe you could talk a little bit about the patent process and how you got involved in it with the European patent, being finalists. I'd love to hear a little bit about that, because that's very special. So it's not, you got an set of inventions, you got a company started, that's success. Maybe that's enough success, but it's going to be more success. But then all of a sudden you're notified that you wanted the finalists. How did that go?
It was exciting. It's an honor, and say we're both very proud of this. Excited that so many people can see the impact of this. I think that's what it says to me, is that it's very easy to see the magnitude of opportunity that there is with an application like this.
Right. And so, I mean, maybe Kripa, tell us a little bit how you got notified by the patent office. I mean, I'm sure you understand the patent process given your experience, but this must have been a different thing.
Yeah, so we, as I said, when we were at MIT, we having worked before in industry, especially at GE, helped me understand how patents are written, how one should draft them to get better claims, and so on. So that training was very helpful. And when I came back to MIT, I tried to instill that in all of my students and group members. So with Dave in particular here with this, as you can imagine, we had a gold mine kind of, and we had to protect this. So we went back to the basics of, hey, why does this work? What are the foundational things, and really went for the article along with number of follow-on things. And and MIT has been amazing and helpful in really helping us patent and get the help to file all these. And then we were asked about, hey, which other countries you want? And of course, we knew markets, US is a big market, Europe and Asia. So we wanted this filed everywhere. And in that process, we ended up filing PCT and, getting to all the European countries. And we have patents granted in Europe. And suddenly, just a few months ago, we get an email from the European Patent Office saying, hey, you've been selected as finalist. And the first day I almost like missed, thought, okay, this is real. Or something.
Email, right? Yeah.
And then the person from there was very kind, followed up again saying, do you want to accept this nomination? And then we were like, yes, accept the nomination.
Yeah. Wow.
And so we were, of course, very thrilled and honored to be nominated, and looking forward to the occasion. I think it's great that the European Patent Office is doing this as a celebration of inventors, and I think it's quite amazing what they've done.
Yeah, I totally agree with you. I think the motivation of inventors is sometimes really fragile, and to have an esteemed group like the European Patent Office come out and have a program like this to recognize people gives you another reason, to want to work for stuff. And so I think it's really kind of amazing that you were chosen. And now I think there's down to 3 finalists, and you have one of the 3. So I know that people watching this will put the link that they can get onto the website, the European Patent Office, and really vote for you guys. So this is really just kind of very, very special and amazing. So I'd like to, have one more kind of question, because we could, like I said, from the inventor standpoint, there's just so much to talk about. But given, this recognition, given the successful company, given that you have been awarded these patents, what do you guys, go to each one of you? What do you guys see as the future for the two of you? Where does this take you? So maybe I'll start with you, Dave.
Let's see. I haven't really thought about myself so much as like what we want this company to do.
Okay.
believe the technology can really change the world. As you mentioned, there are endless applications. We keep learning new applications almost every day, just that come in through our email. And I just want to keep helping this company to make the biggest impact possible.
Got it. And how about you, Kripa? What do you see as the future for yourself and the company and the technology?
I'm always amazed by how many viscous products are there around us, right? I get up in the morning, I brush my teeth to, putting a moisturizer, or to coming in, you use a condiment, or, you're surrounded by viscous products. And I think our dream is this becomes the way these are delivered, and I think when we went to consumer packaging, one idea we had was, hey, every person on the planet is going to brush his teeth more or less, and they're going to see this, and they're going to think about many things they could use it on.
I see. Yeah, right.
We have seen people reach out to us. Maybe we have about 10,000 inquiries about, hey, can you use it for this or that or so on, right? So it actually inspires a whole generation of people too. Like, I was just at an airport one day, and people said, oh, the MIT guys figured out this ketchup problem. So it is so ubiquitous almost, and it's everywhere. So, I mean, we really think, there should not be this waste. There should not be this issues with sustainability, as I talked to you about. That could all be gotten in a very visible way here, right? And then you move to other things. For example, like biomedical, we are working on catheters and other biomedical devices, where you can prevent occlusions. This could be life-saving. We're looking at ostomy products, which is life-changing for patients. And then, you could go on to aircraft icing, where today, you spray all this ethylene glycol, which is not good for the environment, and also takes up a lot of taxiing time and other things on. So, I mean, it is liquid solid interactions are everywhere. And so I think our dream is that this becomes a, like the way iPhone changed everything in terms of people, how you use information, our dream is this becomes something like that, where it's used everywhere, and we can really, reap the benefits of this technology.
You have about 100 lifetimes in this thing. Maybe you become a licensing company so that everyone
even we were thinking about when COVID vaccines happened, and every last drop counted there. A technology like this could have the potential to save precious material like that.
Wow. Well, I'd love to talk to you more. Time is always the problem we all have, but once again, congratulations to the both of you for the journey you've taken as an inventor to stick with it. It's great to see a professor and a student together forming a business. I think that's such a special arrangement, which tells many professors and many students to kind of think about that when you go into class or teaching students, that these relationships that can be formed that can really change the world. Then you become successful inventors that get patents and raise money, and then you get recognized by the European Patent Office. I mean, it's just an amazing accomplishment. So I want to thank you both for being, on our show, and I'm hoping that everybody will, when they watch this, will take the next step to go vote for you guys. We're going to do a press release on this as well to get this out, and we just really enjoyed having you and love to talk to you more later on. So this is John Cronin from Invent Anything in our channel Inventors at Work, and we certainly see a couple of inventors at work, don't we? Thank you so much, Kripa and Dave.
Thank you so much, John.
This is Invent Anything's Inventors at Work. Check us out at ipcg.com. And if you're an inventor, tell us about your inventions.